Good afternoon. I hope everyone had a good lunch. If I only provide the service of you falling to sleep to my voice, may you have pleasant dreams. Can I start with a pre-talk selfie? Is that all right with everybody? All right. Everybody say Devoxx. All right. As you mentioned, my name is Spencer GIbb. I've been on the Spring team for almost 11 years. It will be 11 years in June, exclusively on the Spring Cloud project. Today we're going to talk about Spring Cloud Gateway and a new version of it that works in Spring MVC and that works with virtual threads. Just a brief agenda of what we'll do. Basically, my experience with API gateways has 3 episodes, and we'll talk a little bit about each one, and then we'll get to the demo, which hopefully is the most interesting part, and hopefully goes right today. So first, what is an API gateway? Well, for a lot of modern services, we have these APIs that live out on the edge that need to be consumed by our clients, whether those are desktop web browsers, mobile phones, whatever it may be, and we need some way for them to connect to our APIs. And so there is something sitting in between. There's likely a hardware layer in there. In our case, we're going to be talking about a software-based API gateway. And a typical HTTP request, just some basic refreshers. We get in a request, the gateway has to match based on some information in the request before it knows how to send it. There is an optional list of filters that may be applied to that request. Then that request gets sent to the downstream system. When the response comes back, there may be filters that run after that, and then we send the response back to the client. So fairly simple what we'll be doing as we go through this. So episode 1, Zuul. Any Ghostbusters fans out there? I see 1 or 2, right? All right. So the kind of joke is it's from Netflix, right? They kind of name things after movie things, and this is from Ghostbusters. Anyway, so when myself and Dave Sire started Spring Cloud many years ago, we incorporated many parts of the Netflix OSS platform, and Zuul was one of those pieces. It is based on a servlet or servlet filter. It had a very, very simple life cycle. And it was, part of the problem was that it was subject to the thread per request issue of servlet filters. It had 4 different filter types, pre, route, post, and error, and it was just a simple for loop that executed and ran through each of those filters. And it came with nothing. It was basically just that little framework, and Dave and I implemented everything that we thought we needed in the early days of Spring Cloud. It had a very awkward API. When you implemented a filter, you had to return an object, but that object was never used anywhere. So you just returned null at the end of your filter. And we only had a way to match by path. So whatever the path was in the URL was the only way we had to match. But it was popular. Netflix used it for years and years. They finally replaced it with Zuul 2. We'll talk a little bit about that later, and they're still using some version of Zuul at Netflix. So when they did announce that they were making Zuul 2, at the same time, the Spring Framework team was working on what is now called WebFlux, and Netflix open sourced a snapshot of their code, and they put it on GitHub. And so I went and looked at it, and at the time I was attending a conference, not as a speaker, as an attendee, and it was nice to sit and think as opposed to worry about giving a talk. And as I was thinking and pondering and looking at all these different things, I I came to the conclusion that it might be easier to make our own API gateway rather than try and integrate Zuul too. So I put together a small little white paper and sent it to folks on my team, and pretty immediately I got thumbs up. Let's do it. Let's build our own. So it's built on WebFlux. So WebFlux is built on top of Netty, which is an event loop system. So this is reactive and non-blocking. It's a great thing for something like an API gateway, right? You can handle a lot of data going through your system. We reuse a lot of the core WebFlux facilities. So if you've ever, who here works with Spring? Can I get a, hi. So you're familiar with the controller methods, right? Request mapping at controller, those kinds of things. So this basically lives as a sibling to those. And it was built using Spring Boot's external configuration files as the way to really drive how you configure WebFlux. And then kind of onto that, we built a DSL. So it was a much better developer experience for those building an API gateway. It was non-blocking, much more flexible routing than Zuul. We could match anything in the request, including the body, right? So headers, query parameters, the body, everything. So those of you who raised your hand, how many of you have worked with WebFlux or Project Reactor? Oh, a fair number of you. Okay. It's a little more difficult than, it's much more difficult than the servlet-based stack, right? So some things can be very complex when you want to do them. And it requires a Netty server, which we found that some companies don't support. They won't support Netty in their company. They want Tomcat or something like that specifically. So, issue 36. When we created it, I said, well, we've kind of eliminated the use case in the servlet stack, right, in Spring Web MVC. So I created this issue, and it was the top voted issue, and it was long-standing, but it just didn't feel right until Project Loom came about. So for those of you who are unfamiliar, Project Loom was about virtual threads, right? So the traditional Java thread was a heavyweight thread. It required context switching, it required memory. So basically, your system was limited to the number of threads by the system hardware, right? Project Loom came into preview in Java 19 and 20. It graduated in Java 21, yay. And our team had been following this from the beginning. We're very excited about it. And in Framework 6.1 and Spring Boot 3.2, we implemented support for virtual threads in the Spring framework. There have been some recent improvements in Java 24 for thread pinning. If you want, you can go read about it. So with all of this coalescing together, my team and I said, okay, I think it's time that we built a Web MVC version of Spring Cloud Gateway. And so we said, let's go. And we did. So first, a demo of setting up a Spring Boot application for virtual threads. Are we all prepared for this very complicated demo I'm about to show you? That was hard. Okay, the demo gods are with me. All right, so it's very, very simple to enable. It's a single property, and I'm joking here a little bit because what happens behind the scenes is fairly impressive. Spring Boot sets up the container, whether that's, initially it was just Tomcat, but I think it has moved into the other containers. Framework and all the thread pools, they all get set up to use virtual threads with this one property, right? So very easy to enable this as we get going. So demo number 1 worked, yay. So let's go ahead and build this. So now this is, when I gave early talks about Zuul and Spring Cloud Gateway, I told people you should never build your own API gateway. But I did. My team and I did. And now I have, this is the third one I built. And people would ask, well, why do you? And I said, I have experience building them now, which is kind of an odd thing to have. So this is version 3, and the number one thing is it's not WebFlux. As I was building it, and I needed to do something, I was like, oh no, this was so difficult in the old version. Oh, and it was sometimes just a few lines of code to do what took me days or weeks with many of my colleagues to get working. It was much, much simpler. So another philosophy difference with the WebMVC version versus the WebFlux was this idea of porcelain and not plumbing, right? In the WebFlux version, I said it was a sibling to @controller, right? So this meant I was deeper into framework using the plumbing, right? I was using things that you, as a developer, wouldn't normally use. And with the WebMVC gateway, I wanted to use the same APIs as a regular developer, not a framework developer. So that's the idea here of porcelain, right? I wanted to use a user-facing API, not the framework API. So what I decided was that who's familiar with the functional version of WebMVC or WebFlux? Do we have any of those? We have a few of them. Great. So rather than the controller-based method of doing a web API, there's a functional way of doing it. And in this case, we have a simple router function. And remember from our previous life cycle of a HTTP request, we have a predicate here. In this case, it's the HTTP method get and this path, okay? You'll see the familiar curly braces in the path, right? This is the same as that you can do in the paths of a request mapping, right? So you can have named path parameters. So this is our handler function. So typically in a controller base, you just annotate your method and it would execute that particular method. In this case, we have to point it at a method. Here we're using a method reference to this person handler that you see here below, getPerson. And it itself is a functional interface. It takes a server request, returns a server response. And then you can add filters to this, right? In a normal controller, you'd do that with like a servlet filter, right? You'd create a bean, and there would be a servlet filter that you could filter either pre or post. In this case, you can add filters here. All right. So now I get to show you another demo, and we'll open this up. Can the people in the back see? Great. All right. Here I'm using the bleeding edge of Spring Boot 3.5, which will be coming out, where are we? April 10th, the end of May. We're using Java 24 here. Here's the URL if you want to go look at why Java 24 is nice. And then we're using the snapshot version of Spring Cloud. A number of things that we're doing here use some of the Spring Boot testing frameworks. So I'll be running a test main method for my gateway. And so this will be using the test containers integration with Spring Boot. Basically, it allows you to run integration tests with whatever container you want. In this case, later I'll be using, for example, RabbitMQ. Most of the demos will be using something called HTTP bin, which is a neat tool that allows you to just send an HTTP request, and it will just return what you sent it. And you can do all sorts of different things with it. But I'll be using a container of that, so my demos always work regardless of whether I have the internet or not, which is nice. So there is that, and then this is my main application here. So here, again, 2 examples of simple functional endpoints, okay? So one that uses the lambdas, like they talked about this morning. When the Spring team got to move to Java 8, it was such a wonderful day. It changed our code base dramatically that we could use lambdas. So here it's just a lambda, and here is a method reference to this function right here. So let's go ahead and run our test application. You can see it's bringing up test containers and things. All right, so here we have, okay, so if you learn nothing today, here's a tool that I use. Who's familiar with curl? Okay, great. I don't use curl anymore. I use HTTPy. Okay, it's available everywhere, and I call it curl for humans, and I'll show you why. So if you learn nothing else today, and you've never heard of this before, you've learned a new tool to make HTTP requests from the command line. So we bring up my terminal. So in all of my demos, and I'll give you the link to this afterwards, I have the HTTPy command to execute that particular function, okay? So here we are. So here you can eliminate, if you don't put HTTP in the URL, it assumes HTTP. If you don't put a host name, it assumes localhost. So you can start with what it doesn't assume, in this case, the port. So /hello. So we get a color-coded, formatted response. When it does JSON, it will make it pretty and everything. So there's your new tool. So hello world. If we want to go to the other one, here is hi, the same, this one here. All right, second demo, done. Cool. Oh, and here's our first one, right? That was the first one. I've got it here, virtual threads enabled. Great. So when I was building this, I'm going to reuse this functional DSL. And it already comes with a bunch of ways to match. We have HTTP method, path. It already has operators for Boolean logic and or and not. You can create custom predicates, which I needed. It already has the concept of a filter, and it even has some shortcuts for before filters and after filters. And it can do nested routes, which is something that people wanted in Zuul and the other and WebFlux Gateway before too. I'll show a demo of what I mean by a nested route. Some of the things I wanted to be explicit as possible. So in both Zuul and the WebFlux Gateway, a lot of things just kind of happen automatically that the developer doesn't know about. In this case, I wanted to be very, very explicit what you were doing, and I'll show you a few examples of that. It's DSL first this time, right? I already have a Java DSL. So I made it, I still need to support the boot configuration file, so I added that second. And I wanted it to be as simple as possible. I also wanted to support the HTTP clients that Spring Framework and Spring Boot supported. So it uses the new REST client that is part of Spring Framework. So this is the blocking analog to web client, right? The builder pattern for making HTTP requests. And underneath of that, we, by default, use the JDK HTTP client that was introduced in 19, I believe. But we support Apache or OKHTTP or Jetty or the old URL connection, but URL connection has some, it has a few problems. But it's there, and we support it. So some of these use cases are organizational requirements. People wanted to be able to use this in a servlet environment. They might only support Tomcat or Jetty. I have people waiting to move over their Zuul apps to this because they wanted it embedded, right? They didn't have a standalone gateway. For example, if you had a standalone WebFlux gateway that sat in front of all your other servlet-based ones, that was fine and didn't matter. But if you wanted to embed it in an existing MVC apps. So a few non-goals. There probably won't be 100% feature parity. There are just some things that we won't be able to do. We're also limited in certain cases by the servlet container themselves, right? Servlet containers do certain things to the request when they come in. And for example, the minute you ask for a request parameter, it will parse the body if it's form URL encoded, right? So it does, servlets have their own life cycle. And there might not be a performance parity. So just be aware. So we did this originally in 2023. In 2024, we've added some of the filters to try to get closer to the WebFlux gateway. In this release this coming year, we've added support for some stream and function handling. So it's starting to mature, right? It's been out for a few years already. All right. Who here has seen my colleague Josh Long speak? A few of you. All right. Let's see if you can answer this question. What is his second favorite place on the internet? What's his first favorite place on the internet? Production, yes. And this is his second favorite place. This is initializer at start.spring.io. I don't do the fancy thing where he zooms in on it when he says it. And let's see, he says, if your kids are upset, start.spring.io. If you have indigestion, start.spring.io. You can see I've filled out some of my preferences here. Maven, Java. We're using the latest Spring Boot. Again, notice Java 24 now. Java 24 is live. Use the latest if you can. There are 2 entries now. If you type gateway, you have gateway here, and you can see in the comments here, servlet-based, and then there will be a reactive gateway, which is the WebFlux-based gateway. Okay? All right. More demo. Yay. So as I go through these demos, I've created them in bite-sized configuration classes so that if you want to go look through this repository yourself, you can see each one of the demos is its own separate Java file. Let's start with just our first route. So this is a normal configuration class, normal bean, and you see this is the same. If we go back to our application, right? It's the same router function here. But instead of, so here, this router function class is from the Spring Framework web package. We're going to use one that is from Gateway. So it's a similar, it's the same API, but it's just a new entry point. So we use the route function, and what this does is it allows us to provide an ID that is used in some of the more complex routes. They need an ID. So again, you can see here, we're going to match on HTTP GET and this path. And this is /anything is from HTTP bin. So what's different here now is that our handler method is this HTTP method. So we have a handler function class from Gateway that has HTTP. And so this is some of the explicitness that I was talking about before. So typically, Gateway needs to know where to send a request. You can either do that via another method here that I've just deprecated, which is why I don't use it anymore, that you can put a URI directly in here, or you need to supply the URL in some other filter. Typically, Spring Cloud Gateway will use the load balancer client to load balance between things. And in this case, this special class here, is just a filter that says, go to the HTTP bin container. So that's what this before filter is. All right, so let's go look at this. We'll get to see some of HTTPie's wonderful formatting. So we scroll up and we can see the response. So here we get all the headers that were sent to us and the URL that we hit, actually. Okay? Very, very simple. So demo 2 is the exact same thing, except I'm not using the shortcut method. So instead of, here was .get, I just say route, and route takes a predicate. So here I'm saying method, HTTP get, and path. So these are functionally identical. So I'm not going to run this one, but it does the exact same. There are more interesting things coming. All right, so we've matched on path. So there is another class in Gateway called Gateway Request Predicates that has a bunch of custom predicates that I'll be showing you. First one is header. So in this one, it doesn't care anything about the path, just the header. And in this case, you can see, thanks to IntelliJ, that this is a regular expression here. This is plain old Java regular expression. So if we run this, and in HTTPie, if you colon separate values, those are headers. If you do equals, it is a JavaScript value. Unless you add the -form parameters, then it's a form value. So we do this, and again, we should see our xfoo, right? This is what was returned. And if I edit this parameter so that it doesn't match, right? Say Baz, we will get should have been a 404. I'm not sure why it's 415. Anyway, we get an error, right? We get a response that, no, something's wrong with your requests. Another more complex predicate is the host predicate. And here you can see we're using some of the globbing from Spring Framework, right? This means any number of segments prior to this, right? So this could be www.myhost, or it could be s01.abc.myhost, right? It doesn't matter how many subdomains this has. So we can run that one, and you can see it matches. And you can see we've added some proxy headers here as well. All right. So now a little more complex. I talked about nested routes. So we have some users that have hundreds or even thousands of routes, and we keep them in a list, which if you have that many, there's a non-trivial amount of time matching if the match happens to be at the end of the list. But if those routes happen to live in some kind of path hierarchy, you can now do nested routes. And so you can shortcut that matching with nested routes. So in this case, we will see these two routes go to two different places here. So to nested one, and then nested two. Like I said, this is for a performance optimization if you have a lot of routes. Let's close some of these. So here's another, our most complex predicate is reading the body. So here we have a read body static method, and we're going to match, in this case, we're going to tell it it's a string. You can use any object that you want. This uses the conversion service inside of Spring Framework to convert based on whatever the content type of the body is. It will do that conversion for you. In this case, it's just simple and it's a string. So we got to make sure that the body of this is hello world. So in this case, you're seeing that these are JavaScript values. Okay, so it matched. And here we can see the data that was sent was hello world. Yes, so the warning with reading the body is that we read it all into memory, right? So you've now become memory constrained if you start to read the body in like this, okay? So we start to get into some filters. We have a number of these. I'll have to pick and choose, I think, based on my time left. So let's do a basic one to begin with. So a normal route that we've seen, and now we have add request header. So if we come back here to our imports, there's a class called before filter functions. These are all filters that can only use the request data. So if we go look at this, the signature of this, it is a function that takes the server requests and returns the server requests. So you can modify the server requests, but that's all the data that you can act on. So in this case, we're simply adding a request header. Okay? Very simple thing to do. And these were so much easier to write, these filters, than they were in the WebFlux version. So we can see that our xfoo header was added. Let's do set path here. We're going to again do the host predicate, but I want to use this curly brace syntax in our matching. So what this does is it saves it into what we call request attributes, and then those request attributes are available to be replaced in filters later. So if I run this, this means that the request to the downstream service should be to /anything/www, okay? And you can see that that's what happens. My demos are really boring. There's not a lot of exciting things going on, but because it all happens behind the scenes, but I hope that you get an idea of what's going on. So you can also change the status of a response. So this is an after method. So this HTTP bin method /status says just return a response that's 502, but we're going to change it to a 401, right? So we're basically intercepting the status back. Okay, and we get a 401 error. So now we get to some more interesting filters here. Let's do the load balancer one. So this uses Spring Cloud Load Balancer under the hood, right? Typically, you'd use this with a discovery client, so some kind of service discovery, whether that's Eureka or Console or Kubernetes or something like that. And you just provide a service ID, and then it picks the right one to do. So I'm doing some hand waving and magic down in this bean here, because we don't have a real service discovery client behind us. But it's giving you the same kind of thing. So this is how you would do a dynamic URL for the gateway. So we went to /load balancer, and we have our request header x test. There we are. Let's do the bucket4j. So we have rate limiting built into the gateway. It's a real interesting token bucket algorithm that if you want to go read a white paper, this is a very simple one, but basically it models a physical bucket with tokens that get put in it every so often, and then when a request comes, if there's a token available, it will pass through, otherwise it will get a 429. And Bucket4j has many backends that you can use for distributing the token count for each route. In this case, we're just using an in-memory version. So we configure it that the bucket only has a capacity of 1, and it gets refreshed every 5 seconds. So it's a very sad bucket. But it makes an easy test because I should be able to see it fail fairly quickly with a 429. And it needs a key to keep track of the tokens. And in this case, we've just hard-coded that key. So -H says I want to see the request headers, or just the headers in the response. So if I do this and do it again, so our first one went through and our second one was a 429. We have support for a circuit breaker. This is modeled as the physical circuit breaker in an electrical system, right? When you start to get too many errors, the circuit will open and it will send you to a fallback. And in this case, our fallback is another route here. And with this fallback headers filter, and I can show you what that does. So what it does is it adds some headers so you could see as a developer what the exception was, and you could take appropriate action depending on what kind of exception happened. In this case, it was a simple timeout exception. We have support for retry. You can do configuration from refreshing. One I wanted to get to show you was some of the new functionality that we've recently added. This is a integration with Spring Cloud Stream. So Spring Cloud Stream is a message-driven way to write microservices. And this allows you to send, it binds to whatever message source you have, whether that be something like RabbitMQ or Kafka or whatever it may be. And so what we've done recently is we've wired up Spring Cloud Gateway to be a front end to your messaging system, which we've had a lot of people very, very interested in. And so what you see here is a new handler here called Stream, and this is simply a binding name. And then, let's see, in my configuration file, I have some configuration here to route this to the appropriate place in RabbitMQ. And then the other bean I have defined here is a consumer, right? I just want to see when that message gets put on the queue, I want to see that somebody gets it. So here's this little line of configuration says, this is how I'm going to consume this this message queue. So if we run this guy, hopefully this will work. So this is how you send raw data to HTTP. You can just pipe it to it. So we got a really fast response, right? Because this is a send and forget. But if I go back to my console here, right, I had a log message, log.error, and you can see here that we consumed our message from RabbitMQ, right? So you can now send messages via Spring Cloud Gateway. And there are a number of other things that we didn't get a chance to look at. We can modify request and response bodies. There was retry, which is very nice to have. I want to retry this 3 times, and a few others. But they are all documented, how to test them, and to see it happening in the logs. So this is the URL. If you want to take any picture, this is the one, because that whole demo will be there. And I will put a PDF of these slides in the root of this this repo as well. And if you're on the internets at all, anybody? Anyway, like, you can get me at these places. I think we're out of time, so if you want to ask me a question, you can follow me out to the hallway track and ask away. So I appreciate your time. I know there are lots of great options today, so thank you for coming to hear me speak. I appreciate it.